Okay, so we're looking at the University of Washington's Math 120 pre-calculus. We're considering midterm 2, question number 3. We're given a function f of x equals x squared plus 3 to the x, and we're asked to consider some transformations of this function, and finally write a formula for a new function g after applying these 3 transformations. So the 3 transformations we're asked to consider are first scaling horizontally by a factor of 1/3, then shifting our graph 4 units to the left, and finally reflecting across the x-axis. If you haven't already, pause the video and see how you do with managing these transformations on your own. So we'll first consider each of these shifts separately, and then afterwards go through and actually put them together. Okay, so let's go ahead and dive in. This first transformation is the one that I always find the trickiest. We can handle vertical scaling relatively easily, but somehow I always feel a little mixed up when I'm dealing with horizontal scalings. So in order to scale this by a factor of 1/3, I've gone through and I've replaced every instance of x with 3x. So where I had x squared, I now have 3x squared, and where I had 3 to the x, I now have 3 to the 3x. Why does this scale by a factor of 1/3 and not, as you might think, by a factor of 3? Well, let's consider what happens if we plug in 1 to this new function here. If we plug in 1 to this new function here, we end up actually computing 3 squared plus 3 to the 3rd, which is as if we had plugged in 3 to this initial function here. So when we plug in 1 to this, it's as if we plugged in 3 to this, and that's exactly the type of scaling that we were looking for. So let me ignore this transformation and consider these 2 transformations, again, each separately. So we're going to pretend that we hadn't already made this transformation and just go back to considering our initial function. How do we handle shifting 4 units to the left? Well, I guess I'll use h here. When I think of shifting 4 units to the left, what I think of is I want to write my new function so that when I feed 4 into this function, it's as if I fed 8 into this function. And if I feed -4 into this function, it's as if I fed 0 into this function. So how can I do this? Well, in particular, I can just write my new function as f of x plus 4. In other words, I can write my new function as h of x is x plus 4 squared plus 3 to the x plus 4. And this final transformation is actually quite straightforward. To reflect across the x-axis, we're simply flipping everything upside down. I can simply write, I'll use j. I just need to change the sign of everything. So here, again, going back to just my original function, I'm for right now not considering combining all 3 of these, right now just doing these one at a time. Okay, so we've considered each of these transformations separately. Let's go ahead and do them now consecutively. So we'll start from our original function. I'm going to label these new functions as g1 of x, g2 of x, and then g3 of x. So g1 of x will be after this first transformation. We've already written it here. Let me just recap. The way we write g1 of x is we take our original function, but we write 3x in place of x. Now, I want to take g1 of x and transform it. In particular, I want to shift it 4 units to the left. So my new function, g2 of x, will be my old function, g1, but this time, instead of with an argument of x, we'll have an argument of x plus 4. So in particular, our function after our second transformation is written like this. The only difference between this g1 of x and this g2 of x is that I've replaced each x here with x plus 4 here. And now finally, our final function, which we could call g3 of x, this is what the question asks us to call g. I simply need to write g3 of x as negative g2 of x. So this is a 3 with a parentheses. And this is what we'll call g of x. So here is my function after all of these transformations. Writing this all in one step, I could say that g of x is negative f. We can say that g of x is negative f of 3x plus 4.